Hello everyone, this is John Hashmat and welcome to Physics Simply. In this video I will be solving the paper 4 exam for May-June 2021, variant 1. So let's get started. Question 1 says a skydiver of mass 76 kilograms is falling vertically in still air. At time t equals 0, the skydiver opens his parachute. Figure 1.1 is the speed time graph for the skydiver from time 0. Using figure 1.1, determine the deceleration of the skydiver immediately after the parachute opens. So we use the gradient of the graph because acceleration is equal to the gradient of a speed time graph. So if we start with this point here, we have 58 on the y-axis and 0 on the x-axis. We can choose another point which is at 0.5 seconds. Here we have the speed 40. So we use y2 minus y1 over x2 minus x1. First we say acceleration is equal to the gradient and y2 is equal to 40, y1 is equal to 58, x2 is 0.5 and x1 is 0. That gives an answer of negative 36. So the deceleration is 36. If acceleration is negative, deceleration is positive. And the unit here is meters per second squared. Part II requires a force due to air resistance acting on the skydiver immediately after the parachute opens. So we say that the force with motion, which is equal to the weight, mg, minus force against motion, which is air resistance, is equal to the mass multiplied by acceleration. And the weight here is 76 kilograms times 9.8. We then subtract air resistance. That is equal to the mass 76 multiplied by the acceleration, negative 36. So if you move air resistance to the right side as positive and then replace it with positive 76 times 36, we get a value for the air resistance at 3480.8. So we can approximate that to 3480 newtons. Part B says explain in terms of the forces acting on the skydiver, his motion between time 0 and time 6 seconds. The graph was decreasing speed with decreasing gradient, that is decreasing acceleration. So we say that at first air resistance is greater than the weight, so speed decreases. And then we say as speed decreases, air resistance and resultant force against the motion decreases. So deceleration also decreases. That's why we have a decreasing deceleration. Part C says explain why opening the parachute cannot reduce the speed of the skydiver to 0. We say that at 0 speed there is no air resistance to balance the weight. So this causes acceleration downwards with the weight. So whenever there is an acceleration, the speed cannot stay at 0. Question 2 says figure 2.1 shows a wooden trolley of mass 1.2 kilograms at rest on a rough surface of a bench. A ball of mass 0.52 grams travels horizontally towards the trolley. The ball embeds itself in the wood of the trolley. The trolley moves with an initial speed of 0.065 meters per second. So this is also the speed of the ball. Part AI says calculate the impulse exerted on the trolley. So the impulse is equal to the change in momentum, which is equal to mass multiplied by the change in velocity. We have the mass 1.2 and the final velocity 0.065. Initial velocity is 0. That gives an answer of 2.4 kilograms meters per second or Newton second, either unit. Part II says calculate the speed of the ball as it hits the trolley. We can use the law of conservation of momentum. We can use m1u1 plus m2u2 is equal to m1v1 plus m2v2. m1u1, that would be the mass of the trolley multiplied by 0 because it was at rest. And the initial velocity of the ball is unknown, so we just take the mass of the ball, which is 0.52 grams, so 0.52 divided by 1000 to get it in kilograms, to keep all the masses in the equation in kilograms, multiplied by u2, the unknown, and the final momentum of all the objects, that is a combined mass 1.2 plus 0.52 over 1000, all moving with a velocity of 0.065. So first this cancels out and we can divide this section here on the other side. So we divide the right hand side by the fraction 0.52 over 1000. That gives an answer of 150 meters per second. Part B says as the trolley moves across the rough surface, it slows down and stops. Explain in terms of the work done, the energy change that takes place as the trolley slows down. So we say that some of the kinetic energy is used as work done against friction and converted to heat energy or thermal or internal energy. Question 3a says, explain in terms of molecules why liquids are very difficult to compress. We say that because molecules are already very close to each other and have very strong intermolecular forces. Question B says, figure 3.1 shows a device that uses liquid pressure to lift heavy boxes. We have a pump pushing the liquid, and the liquid is oil here, which pushes the piston upwards, carrying the heavy boxes. The boxes are lifted by pumping oil into the cylinder. The force upwards on the piston due to the oil and the force downwards on the piston due to the air above the piston combine to produce a constant force of 8,800 newtons. The pressure of the air is 1 times 10 to the power of 5 Pascal, and the cross-section area of the bottom face of the piston is 0.016 meters squared. Calculate the pressure of the oil at the bottom surface of the piston. So we have the piston here, and there is a pressure from the top acting downwards and the pressure from the bottom acting upwards, and the resultant of these pressures is equal to the resultant pressure pushing the piston upwards. And we can calculate the resultant pressure here using the equation force divided by the area. The resultant force was 8,800 and the area here was equal to 0.016. That gives a difference in pressure of 550,000 Pascal. And that difference, 550,000, is equal to the difference between the two pressures, the pressure due to the oil minus the pressure due to the atmosphere, which is 1.0 times 10 to the power of 5 Pascal. We can then add 1 times 10 to the power of 5 to the other side to get the pressure of the oil. That gives an answer of 6.5 times 10 to the power of 5 Pascal. Part I says, as the boxes are lifted, the depth of the oil increases. Explain why the pump must exert an increasing pressure on the oil as the depth of the oil increases. So we say that as depth increases, the pressure of the oil at the bottom increases. So the pump must supply a greater force. So as pressure increases, the force also increases. I says, suggest one reason why the force 8,800 newtons and B cannot lift boxes of weight 8,800 newtons. We say that if there is no resultant force, there is no change in motion. So it must be at first at least a force of greater than 8,800 newtons. So the object starts to move, then the force can decrease back to 8,800 newtons. Question 4 says, an aluminum saucepan with a plastic handle contains cold water. Figure 4.1 shows the saucepan on a hot plate. State why the pan is made from aluminum but the handle is made from plastic. We can say that aluminum is a good conductor and transfers heat quickly to the food, while plastic is an insulator, so it will not transfer heat to the hand. Part B says the hot plate is switched on, and as the temperature of the water increases, the internal energy of the water increases. I says, state in terms of molecules what is meant by an increase in internal energy. It is an increase in kinetic energy or potential energy of the molecules or the particles. Part I says, explain in terms of the atomic lattice and electrons how thermal energy is transferred through the aluminum. We say that atoms next to the hot plate vibrate faster and collide with the neighboring atoms, while free electrons travel from atom to atom, transferring kinetic energy. Question I says, eventually the water reaches boiling point. Thermal energy from the hot plate is still being transferred to the water. Explain in terms of molecules the effect of this thermal energy on the water. We say that molecules gain energy and do work against intermolecular forces, and the spaces between the molecules or the atoms increases as some molecules escape the liquid as vapor or as gas. This question is about latent heat, so you can skip this part for the new syllabus. It says the mass of the water decreases by 0.11 kilograms in 300 seconds. The specific latent heat of vaporization of water is 2.3 times 10 to the power of 6 joules per kilogram. Calculate the rate at which the water gains thermal energy. So we need the power First, we can use the equation energy is equal to the mass multiplied by the latent heat capacity, and then we can replace energy with power multiplied by time is equal to ml. Then we can move the time to the other side, so power, which is required in the question, is equal to ml divided by t. So the power is equal to the mass 0.11 multiplied by the latent heat capacity 2.3 times 10 to the power of 6, and then divided by the time, which is 300 seconds. That gives an answer of 843.3 recurring, so we can approximate that to 843 watts or joules per second. Question 5 is about thermometers, so you can skip this whole question for the new syllabus. It says figure 5.1 shows the structure of a liquid and glass thermometer. The bulb of the thermometer is placed into a beaker of warm water. As the liquid expands, it moves along the tube. Explain in terms of molecules why a liquid expands when heated. We say that molecules gain kinetic energy and collide with each other, so the spaces between the molecules increase. Question B says explain in terms of molecules why a liquid expands more than a solid when heated. That is because the forces between liquid molecules are weaker than in solids. So for the same work done, the distance increase is greater. Since work is equal to force multiplied by distance, so as force decreases, distance increases. Part C says a second thermometer has a larger bulb that contains more of the same liquid than the thermometer shown in figure 5.1. It has a different scale. In every other way, it is identical. Explain how the sensitivity of the second thermometer compares with the sensitivity of the first thermometer. So we say there is more liquid, so there is more expansion per 1 degree Celsius. So sensitivity is higher or greater. Part I says explain how the range of the second thermometer compares with the range of the thermometer in figure 5.1. So if it is the same length of the thermometer with longer divisions, the range is less because one division is now longer than in the previous one, so it will take less number of divisions, so less range. Part I says state one everyday problem that is a result of thermal expansion. That would be, for example, that parts in a machine have to take more space in hot weather, so they need to expand. Suggest and explain one way of solving this problem. We can leave gaps to allow for expansion, so the parts will not break each other when they are connected together. Question 6 says figure 6.1 is a full-scale diagram that represents a sound wave traveling in air. On figure 6.1, mark 2 points each at the center of a different compression. Label both of these points C. So a compression is where the layers of molecules are close to each other. So for example, this is a compression and this is a compression. We also have another one here. Part B says the speed of sound in air is 330 meters per second. Measure the diagram and determine the frequency of sound. So the thing that we can measure on the diagram is a wavelength from a compression to a compression here. So if you use a ruler and set it at the end of one compression, we have 1, 2, 3, 4, 5.2 to reach the second compression. So the distance here, or the wavelength, is equal to 5.2 centimeters. That is equal to 0.052 meters. And now we can use the equation frequency is equal to speed divided by the wavelength. So 330 meters per second divided by 0.052. That gives an answer of 6,346.15 approximately. We can approximate that to two significant figures according to the numbers in the question. So it will be 6,300 and the unit is hertz. Part C says the wave reaches a barrier. Figure 6.2 shows the wave passing through a gap in the barrier. So it shows diffraction. The frequency of the wave is increased, which means the number of waves per second increased to a value many times greater than the value obtained in B. Describe and explain two ways in which the diagram representing the wave with a greater frequency differs from figure 6.2. So if the frequency increases, that means that the wavelength decreases, or the distance between compressions or wavefronts decreases for the same speed. And now the wavelength is much shorter than the gap size, so there will be less diffraction or less spreading of the wave. Question 7 says figure 7.1 represents an alternating current generator. A student rotates the handle H as shown in figure 7.1. On figure 7.2, sketch a graph to show how the electromotive force between the terminals X and Y varies with time during 2 complete revolutions of the coil. So we have alternating current with the peaks equal on each side, positive and negative. So we limit ourselves here with equal amplitudes, and we want to be as neat as possible. So if this is half an oscillation, this is a complete oscillation, another half, another oscillation. So we reach a maximum between these 2 points. So here, and the maximum here, a maximum here, and the maximum on the other side here. And then we connect these points with the peaks. So we draw a wave-like diagram. It must be curved, not straight lines. So draw it as neatly as possible. So we have 2 waveforms, that is 2 revolutions. Part I says on figure 7.2, mark and label a point P for the EMF when the coil is horizontal, as shown in figure 7.1. When the coil is horizontal like this, it has the maximum rate of cutting the field. So 1 point is moving up and 1 point is moving down, and the field is horizontal. So it has 90 degrees motion on the magnetic field. So this would give a maximum potential difference or maximum EMF. So we will choose one of the peaks, either at the top or at the bottom. It doesn't matter. It must have a value of maximum EMF. That's just the one condition. Part I says the student turns the handle more quickly. State 2 ways in which the EMF between terminals X and Y changes. So it will have higher peak EMF or voltage and shorter period or periodic time or greater frequency. This is because the rate of cutting the field increased. Part B says terminals X and Y are connected to the primary coil of a transformer. State and explain what happens in the transformer as the student turns the handle of the AC generator. We say that the AC induced in the primary coil creates a changing magnetic field, and that the change in flux in the secondary coil induces an alternating current also. Question C says explain why the power losses in transmission cables are lower when electrical energy is transmitted at higher voltages. We say that there is a lower current, so there is less heat energy losses or wasted. Question 8 says a student sets up a circuit that includes a 12-volt battery, an 800 ohm resistor, a voltmeter, and a thermistor. Figure 8.1 is an incomplete circuit diagram because the symbol of the thermistor is missing. The thermistor is connected between the terminals P and Q. Complete figure 8.1 by drawing the symbol for the thermistor between P and Q. So a thermistor is a rectangle drawn like this with a spatula drawn across, and then we connect it to P and Q. Part B says a 12-volt battery consists of 8 identical cells connected in series. Calculate the electromotive force of each. So we divide the 12 volts by the number of the cells. That gives a voltage of 1.5 volts for each cell. Question C says the reading on the voltmeter is 8 volts and we want to determine the resistance of the thermistor. So we have a potential divider here with a resistance of 800 ohms and another resistor, which is a thermistor, with an unknown resistance. And the total voltage across the whole circuit is 12 volts. And this voltage here is 8 volts. So the remaining voltage on the upper side is equal to 4 volts. And in a potential divider circuit, the voltage is proportional to resistance. So if 800 ohms takes 4 volts, how many ohms receive 8 volts? So we do cross multiplication, 8 times 800 divided by 4. That gives an answer of 1600 ohms or 1.6 kilo ohms. Part I says a few hours later, the student notices that the reading on the voltmeter is greater, which means more voltage, so the resistance increased. Explain what can be deduced from this observation. So we say that the resistance of the thermistor increased, so the temperature must have decreased, because temperature has the opposite effect on the resistance of a thermistor. Question 9 says there are 3 naturally occurring isotopes of hydrogen, hydrogen 1, 2, and 3. The nuclide notation for hydrogen 1 is H1 and 1. Write down the symbol using nuclide notation for hydrogen 2 and hydrogen 3. So they have the same proton number, so 1 at the bottom, that remains the same. So for 2 we have 2 at the top, and for 3 we have 3 at the top. Part B says in a fusion reactor, a nucleus of hydrogen 2 and a nucleus of hydrogen 3 undergo fusion. State what is meant by nuclear fusion. That is when 2 light nuclei join together to form a heavier nucleus and release energy from the reaction. Part I says the fusion reaction produces a free neutron and one other particle. Write down using nuclide notation the equation that represents this reaction. So we have hydrogen 2 here, 2 and 1, and the hydrogen 3, 3 and 1. That gives a neutron, which is 1 and 0. You must memorize that. And another particle, which balances the equation. So 2 plus 3, that's 5. 5 minus 1, we have remaining number 4. And 1 and 1 form 2. 2 minus 0, that gives us 2. And we already know a particle which has the numbers 4 and 2. That would be the alpha particle or the helium nucleus. Question C says nuclear fusion in the sun is a source of most but not all of the resources that are used to generate electrical energy on Earth. State 2 resources for which nuclear fusion in the sun is not the source. So we choose geothermal energy or tide energy, which depends on the moon, or nuclear fission reactors. All these do not depend on the sun as a source of energy. So this was the end of the exam. I hope you enjoyed this video and found it useful to you. Keep practicing and I will see you in another video.